So let's set up some rules for absolute value inequalities. If the absolute value is greater than A, that means that we're going to shade outside and not include A. If the absolute value is greater than or equal to A, we are still going to shade outside, but this time we do include A. If the absolute value is less than A, that means that we're going to shade inside and not include A. And finally, if the absolute value of X is less than or equal to A, we still continue to shade inside, but this time we do include A. The steps that we're going to take to solve an absolute value equation are going to be, first, we have to isolate the absolute value expression. And this is mainly to make sure that we don't get an absolute value that is less than or equal to a negative number. Then we're going to create the equations to solve, graph the points in the number line, shade according to the inequality, and then write the solution to the interval notation. I know that it seems like a lot of steps, but we're taking it one at a time. So let's begin. In example 10, it reads, the absolute value of x minus 1 is less than or equal to 3. So we start with the equation. The absolute value of x minus 1 is equal to 3. So how do we read this? This one reads that x minus 1 is 3 units away from 0. So we have two equations to solve. That is that x minus 1 could be at positive 3, because 3 is 3 units away from 0. This tells you how far from 0 you're going to start. Or it could be that x minus 1 is at negative 3, because negative 3 is still 3 units away from 0. We begin to solve. For x minus 1 is equal to 3. First, we move anything that is being added or subtracted, and that is that minus 1. So on the left side, we are left with x minus 1 plus 1 will get eliminated, and on the right side, that will be a 4. So then my first value that I have to go find in the number line will be that 4. So here it is, 4. Let's mark it. Then we solve the second equation. Again, we move anything that is being added or subtracted. So from left to right, I'm left with x minus 1 plus 1 will get eliminated, and minus 3 plus 1, different signs, we subtract and keep the sign of the largest. So this is minus 2. So then I go and I locate it in the number line. The next step is to go and check the inequality. This inequality states that you want the distance to be less than. So if it's less than, we're going to shade inside. Because it's less than or equal to, we're going to include that negative 2 and the 4. After that, all we have to do is read the number line from left to right. So this number line is being shaded from negative 2 all the way to 4. So from negative 2 to 4, and we include those values. And this is the result for example 10. Let's try another one. Let's go through the steps again. First, we need to isolate the absolute value expression. We need to check in which side of the inequality is the absolute value. In this case, the absolute value is on the left side of the inequality. Then we check, is there anything outside the absolute value on that same side, on the left side? And there isn't. So since there isn't anything outside the absolute value on the left side of the inequality, that means that our expression has been isolated. Then, since this is less than, I have to make sure that we don't have a less than or equal to a negative number. And we don't. This is a positive 4, so then we are okay. We move on to number 2. We need to create the equations to solve. The equation that I'm going to solve is going to be the absolute value of 5x minus 6 is equal to 4. And this is going to help me find the numbers that are going to go in the number line, because this reads that 5x minus 6 is 4 units away from 0. Either 5x minus 6 is located at positive 4 or 5x minus 6 is located at -4, because both +4 and -4 are 4 units away from 0. So let's solve the first one. I'm going to first move anything that is being added or subtracted. So then this is going to give me 5x minus 6 plus 6 will get eliminated. And on the right side, I have 4 plus 6, which gives me 10. Now, I'm not finished because this time this x is being multiplied by 5. So I'm going to divide both sides of the equation by 5. On the left side, 5 divided by 5 will be 1x, or just x. And on the right side, 10 divided by 5 will be 2. So then that is the first value that I'm going to mark in my number line, that 2. I have to keep track of that. Then I move to the second equation. Again, we add the 6 from left to right. That gives us 5x. The 6's get eliminated. And on the right side, -4 plus 6. Different signs we subtract, keep the sign of the largest. So then that will be +2. And then from there, we're going to divide both sides by 5. And 5 divided by 5 will be 1x, or just x. And on the right side, I still have 2 over 5. I cannot divide 2 by 5 evenly. You can put it in the calculator, get 0.4. Why are we changing this fraction into a decimal? Just to make it easier on us where that 2/5 is located. And since this is 0.4, 0.4 is somewhere between 0 and 1, a little less than half. So then right here, I'm going to place 2/5, and we mark that value. Okay, so we have done the following. We have checked that the absolute value was isolated. We created the equations and we solved them, and we have marked them in the number line. The next thing is to go check that inequality. If I go and I check the inequality, I'm going to notice that this is less than 4. So that means that we're going to shade in. I'm going to shade between the two values. And because it doesn't have that little line underneath it, we do not include the values. So then we're going to place parentheses around these. So our solution, reading the number line from left to right, is shaded from 2/5 all the way to 2. Since we are not including the values, we place parentheses. Let's try it again. 11b reads, the absolute value of 2x minus 3 is greater than or equal to 5. Then the equation we're going to solve is the absolute value of 2x minus 3 is equal to 5. That means that 2x minus 3 is 5 units away from 0. So then it can be located at either 5 or 2x minus 3 can be located at -5, because both 5 and -5 are 5 units away from 0. Let's start solving. I add 3 to both sides. We first move anything that is being added or subtracted. From left to right, I get 2x. Minus 3 plus 3 gets eliminated. And on the right side, 5 plus 3 is going to equal to 8. We're not done. We need to divide by that 2 that is multiplying x. So from left to right, 2 divided by 2 is 1x, or just x. And on the right side, 8 divided by 2 will give you 4. So we mark the 4 in the number line. We move to the second equation. First, I'm going to add 3 to both sides. We move anything that is being added or subtracted. From left to right, that gives me 2x. The 3's get eliminated. And on the right side, -5 plus 3 will give us -2. We need to divide by that 2, both sides. From left to right, 2 divided by 2 will be 1x, or just x. And on the right side, -2 divided by 2 will be -1. So we mark that in the number line. We cannot lose that. So now we need to go back and check that inequality. This one states that it's greater than or equal to 5. So we're going to shade out. That means from 4, we shade outside to the right side to positive infinity. And from -1, we shade out towards negative infinity. We are including the values. So we place brackets at -1 and at 4. And we're ready to write our solution in interval notation. We read the number line from left to right, so that will be -infinity to -1, and then again from 4 to infinity. Because we are including the numbers, we place brackets at -1 and 4, and we always place parentheses at infinity. Because our solution is broken into two pieces, we place the union.
Thank you so much for watching, and I'll see you in the next one.